My name is Jonathan Hicks and we're doing converting areas and volumes. Now, this is a topic that catches a lot of people out. What do I mean by it? Let me give you a very quick example. Imagine we had a rectangle here and I tell you that the area of this rectangle is 3.6 meters squared, and I asked you to convert this into centimeters squared. So you got 3.6 meters squared. We want to know what that would be in centimeters squared. And most people, when they see this, think, well, there's 100 centimeters in a meter, so I'm just going to times this by 100. If you do that, you're going to get the wrong answer. And that's what this topic is about. It's how do you convert areas, and volumes we'll come on to later, without making this very common mistake of simply multiplying or dividing by how many centimeters are in a meter. Why can't you do that? Let me explain. For this, I want to draw a meter square on the board, 1 meter square. Now my board is probably not quite big enough for this, but just imagine that this square is a meter high and a meter wide. So broadly speaking, if we say that that's a square, so the width of this square is 1 meter, which means in centimeters it's going to be 100 centimeters. And the height or the length of this square, well, obviously it's a square, so it's going to be the same. So it's 1 meter from the bottom to the top, which again is going to be 100 centimeters. So this is 1 square meter because it's 1 meter wide and 1 meter high. So the area of this in square meters is 1. It's 1 square meter. The area in square centimeters, though, is 100 times 100. So it's not 100 square centimeters. It's 100 times 100 square centimeters. And 100 times 100 is another thing that catches a lot of people out. It's not 1,000. If you have 100 and times it by another 100, you need to add 2 zeros on the end. So 100 times 100 is actually 10,000 square centimeters. So 1 square meter is 10,000 square centimeters. So if you're converting from square meters into square centimeters, you don't multiply by 100, you need to multiply by 10,000. Effectively, because it's 100 squared. So let me give you an example then, if we rub this out, and then I'll explain the same thing for volume. So again, if we go back to our rectangle, perhaps make the calculation slightly easier this time. If we imagine that the area of this rectangle was 8 square meters, and we want to find out what 8 square meters would be in square centimeters, because there are 10,000 square centimeters in square meter, we have to multiply this by 10,000. So 8 square meters is going to be 80,000 square centimeters. That's how you do the conversion. You're timesing, in this case, by 10,000 because there are 10,000 square centimeters in every 1 square meter, which is quite surprising. If you imagine one of these little square centimeters, I don't know if you ever played with the square centimeter grids and things when you're at primary school, but in 1 square meter you get 10,000 of those little square centimeters. Now volume is a very similar idea and catches people out even more than area in a sense. So if we go back to our square meter here, except now I want you to imagine that it's going to stick out from the board here by a meter. So imagine I've got a meter cubed. So I might be able to it's going to be difficult here, but if I extend this back, so imagine that that's a meter cubed. So it's as deep as it is high and wide. So it's a meter wide. Let's put it this over here this time, a meter high, and then it's going to go backwards. It's going to be a meter deep as well. So the volume of this cube is 1 cubic meter, 1 meter cubed, because it's a meter wide, it's a meter high, and it's a meter deep. But in cubic centimeters, well, 1 meter high, again, that's going to be 100 centimeters high. A meter wide is going to be 100 centimeters wide, and a meter deep is also going to be 100 centimeters deep. So the volume in cubic centimeters, sorry, is going to be 100 for the height times by 100 for the width times by another 100 for the depth. Now, 100 times 100 times 100. Well, 100 times 100 was 10,000. You have the 2 zeros from the first 100 plus another 2 zeros, multiplying by this one, so 4 zeros. And then times by another 100 gives you another 2 zeros on the end. Now if we look at this in groups of 3, so that's one group of 3, that's another group of 3, you've actually got 1 million cubic centimeters. Yeah, I know, isn't that surprising? 1 million cubic centimeters fits in every single cubic meter. So if you have a cubic meter, if you can imagine something that's a meter wide, a meter long, and a meter deep, then you'll fit 1 million of those little cubic centimeter blocks in them. If you remember playing with those, these little blocks, certainly at primary school, we'd have to line up the little cubic centimeter wooden blocks and things. You can fit 1 million of those in 1 cubic meter. That's a lot. So if you're converting, if we do a quick example now, if you had some kind of cuboid, for example, I might tell you that the volume of this cuboid is 3.5 meters cubed. To convert that into cubic centimeters, we'd have to times this by 1 million. So in this case, it's going to be 3.5 million cubic centimeters, or 3,500,000. Which is, as I say, a lot, and really quite surprising. And that, as I say, catches a lot of people out. So for area, there are 10,000 square centimeters in a square meter, but for volume, there are 1 million cubic centimeters in a cubic meter. Now let me just try and generalize this for you, because you might find this helps if you ever need to convert any other sorts of areas or volumes other than those standard ones. Okay, so if we had some rectangle, let's say, and I tell you that the area of this rectangle is, let's say it's 462 square centimeters. Now, if you were converting into meters squared, for example, then we'd have to either times or divide by 10,000. So depending on which way you go, obviously if we're going to a bigger unit like meters, you need less of them, so in this case we'll be dividing by 10,000. The reason it's 10,000 is because it's 100 squared. Yeah. So for area, if you're going between meters and centimeters, because the conversion factor is as 100 centimeters in a meter, when you're doing an area conversion, the conversion factor is 100 squared. It's 100 times 100 because of the square meter that I was showing you. So that's why it's 10,000. For volume, the conversion factor, again, because if it's centimeters and meters, is 100 centimeters a meter, it's going to be 100 times 100 times 100, so it's 100 cubed. That's the conversion factor for centimeters and meters. So here, if this is the centimeters to meters conversion. But if I picked a different conversion, if I wanted to do centimeters into inches, for example, well, there are 2.54 centimeters in each inch, more or less. So if you're doing an area conversion, the conversion factor is not 2.54 if you're going square centimeters to square inches, but it's going to be 2.54 squared. Area is always squared. With volume then, the conversion factor will be 2.54 cubed. And in general, whatever it is you're converting, you just take the conversion factor And if it's area, you need to square it before you use it. And if it's volume, you need to cube the conversion factor before you use it. So if we come back to the example here, if you've got a rectangle and the area is 462 square centimetres and you wanted to convert it into square inches, then we'd have to times or divide by 2.54 squared. Because it's area, you must square the conversion factor. So in this case, centimetres are smaller than inches. Yeah, there's 2.54 centimetres in each inch. So if we're going from centimetre squared into inches squared, we're going into a bigger unit, so we need less of them. So we're going to be dividing by the 2.54 squared. So grab your calculator. 462 divided by 2.54 squared gives us 71. If I round this to one decimal place, 0.6 inches squared, or square inches. So that will be how you'd convert an area unit. If you're going into square inches like this, you take the conversion factor and you square it before you use it. That's really important. I won't bother doing an example, but it's exactly the same for volume. So if you had some kind of cuboid here and you had so many cubic centimeters and you were converting into cubic inches, then you would have to divide, in this case, by 2.54 cubed. So this system works for anything, for any kind of area unit, any kind of volume unit, as long as you know how many of the smaller thing fits in the bigger thing for the length scale. So for centimeters and meters, there's 100 centimeters in a meter. For inches and centimeters, there's 2.54 centimeters in an inch. As long as you know the length one, you just have to remember that if you're converting an area, it's the conversion factor squared. If you're converting a volume, it's the conversion factor cubed. So be really careful. As I say, this catches so many people out. They love asking this kind of question on exam papers, and so many people will get this wrong because they forget that for an area you need to square the conversion factor, or for a volume you need to cube it. So be very careful with that one.